The next set of plots we look now is about the distribution plots. Here we look at a histogram, then the density plot, box plot, and Violin plot. So let's begin our journey with the histogram. It's a graphical representation of distribution of numerical data. It consists of a series of contiguous rectangles or bins whose widths represent the intervals of values and whose height represent the frequency of occurrences within each interval. The key features: bars, intervals or bins, frequency or counts. X-axis talks about the range and y-axis about the frequency. So where histogram can be used, the common use cases. So it is useful for visualizing the distribution of the numerical data and identifying the patterns or characteristics. It is useful in assessing the central tendency, spread, and shape of the distribution. So this is commonly useful when we are trying to compare two data sets. Both the data sets are large enough, therefore comparing a value by value is impossible. Then the easiest way is just to find the histogram of the two and find the central tendency, the spread, the shape, and if all of them match, then we can say that the two data set may be from the same experiment. But if one of them don't match, we can just say that they belong to different situations. It will be useful while detecting the outliers or anomalies within the data, useful for comparing the distributions of different data sets or variables I just discussed earlier. So to have a better use, best practices: choose appropriate number of pins so effectively capture the distribution of the data without oversimplifying or overcomplicating it. So if the number of bins is very small, it becomes too simplified, or if the number of bins is too large, it becomes too complicated. So we need to ensure for the given problem what is the best number of pins to use, so that has to be properly taken care of. So we should select appropriate bin width to ensure that the intervals are evenly spaced and will have some meaningful interpretation out of it. And we should consider different methods for determining the bin width, such as Scott's rule, Friedman, Duyckin's rule, and so on. Many such rules are available for identifying the best bin width and move on. Labels to the axis, including the title, will provide a better context and will give meaningful clarity to the histogram. And we must ensure that the bars are visually distinguishable, accurately represent the frequency of observations within each interval. So there's a example of a histogram. So it is talking about two data sets. One data set is represented with orange color and other one is represented with a purple color, and we can easily make out that they belong to two different situations, because the mean of the two do not match, they are different, though the widths are almost equal, but they are placed different positions. Therefore we can clearly say that these two data are not from the same population, they belong to different populations. So that will be a straightforward way to understand whether the data samples are collected from the same population or different population. So that's all about the histogram.